Hello students, welcome to class 11 physics. In this video we are going to solve textual illustration of chapter 6 work, energy and power. So let us see illustration number 1. Find the angle between force given as 3I cap plus 4j cap minus 5k cap unit and displacement d vector equals to 5I cap plus 4j cap plus 3k cap unit. Also find the projection of F on D. So first of all let us see F cap is given as 3I cap plus 4j cap minus 5k cap. D is given as 5I cap plus 4j cap plus 3k cap. Here we need to find the projection of F on D. That means F dot D cos theta. We need to find that F on D, projection of F on D. That means here we are taking two vectors, D vector and F vector, and here we need to find the projection of F on D, and projection of F on D will give us the F cos theta. So we will be getting F cos theta into D. So vector F dot vector D, that will be equal to, we have to take the dot product of this two. So 3I dot 5I, that gives 3 into 5 15, I dot I, that will be 1, and 3I into 4j, that will be 0 because here I dot j will be 0. 3I into 3k, here I dot k will be 0. Then taking 4j with 5I, here j dot I will be 0. Then plus 4j into 4j, that gives 16. J dot j is 1. So plus 16. 4j into 3k, that again will be 0. Now taking minus 5 into 5i, that will be 0 because k dot I will be 0. Minus 5k into 4j, that will again be 0 because k dot j is 0. And taking 4k into 5k into 3k, that is 15. Because here k dot k, that will be 1. So what we get is 15 plus 16 minus 15. Here this gets cancelled out. We will be having 16 unit. Now using the magnitude of F, that is under root of x square component, y component square plus z component square. So here we are having x component of F is 3, so 3 square, plus y component of F, that is 4, that is 4 square, and z component of F is minus 5, so minus 5 square. When we solve this, we get root 50. In the same way, we will be finding the magnitude of displacement. Here we can see that displacement is given as 5i, so 5 square, y component of D 4, that is 4 square, and z component of D, that is 3, so 3 square. So 5 square plus 4 square plus 3 square, that is 25 plus 16 plus 9, that is equals to under root 50. So F dot D, that can be written as modulus F modulus D cos theta. From this we can write cos theta is equals to F vector dot D vector upon modulus F modulus D. F dot D we have found it as 60. Modulus of F and modulus of D, that is magnitude of force and magnitude of displacement, we get it as root 50 root 50. So when we calculate this, we get 16 by 50. So cos theta is equals to 0.32. Now here cos theta can be written as sin 90 degree minus theta is equals to 0.32. So when we see this in the natural sign, we will be getting for 0.32 as 18 degree 40 minute. So here taking theta on the right hand side and 18 degree 40 minute on the left hand side, we get theta equals to 90 degree minus 18 degree 40 minute. So that will be equals to 71 degree 21 minute. Now here we need to find the projection of F on D. that is equals to f cos theta. So now put the values of f and cos theta. Here we got magnitude of f as root 50 and cos theta as 0.32. So when we solve this, we get the value as 2.263 Newton. So the projection of the force on the displacement is 2.263 Newton. So students, you may note down this illustration. Now let us see illustration number 2. It is well known that a raindrop falls under the influence of the downward gravitational force and the opposing resistive force. The latter is known to be proportional to the speed of the drop but is otherwise undetermined. Consider a drop of mass 1 g, that is 1 gram, falling from a height 1 kilometer. It hits the ground with a speed of 50 meter per second. And you need to find over here what is the work done by the gravitational force and what is the work done by unknown resistive force. So here, suppose the raindrop initially at rest, so V0 equals to 0. Thus, its change in kinetic energy is delta K equals to K minus K0. So here we have seen that the raindrop is falling to the ground and we have to find the work done when it drops from a height of 1 kilometer. So let us find the change in kinetic energy, that is K minus K0, final kinetic energy minus the initial kinetic energy. Here the final kinetic energy K is equals to half mv square minus initial kinetic energy, that is half mv0 square. Taking half common, let us take it as v square minus v0 square, half m common. So now putting the values of m, v and v0. Here we have taken initial velocity as 0 because we are considering that at rest, and it is given that the speed of the rain drop, that is 50 meter per second. So here, and its mass, that is given as 1 gram. So you can take it, convert it into kilogram, that is 10 raised to minus 3 kg. So half into 10 raised to minus 3 into 50 square, here it is minus 0. So when we calculate this, we get 1.25 joule, and that is the change in the kinetic energy. Now work done by the gravitational force. Work done by the gravitational force, that is equals to that of the potential energy. So we can write it as Wg equals to mgh because we have studied that that is equals to the gravitational potential energy. So Wg equals to mgh, where mass is 10 raised to minus 3, g is taken as 10, and height here that is given as 1 kilometer. So when we convert that, we get 10 raised to 3 meter. So when we solve this, we get it as 10 joule. Now here from the work energy theorem, we can write change in the kinetic energy is equals to work done. So here the work done by the gravitational force plus the work done by the work done by the gravitational force as well as the resistive force. So the total work done is Wg plus Wr, which is equals to the change in kinetic energy by work energy theorem. So from these equation, we can take Wr as the subject and write delta K minus Wg. Wr equals to delta K minus Wg, because here we need to find the work done by the resistive force. Change in kinetic energy, that we got it as 1.25, and work done by the gravitational force, that we got it as 10 joule. So when we calculate this, we get minus 8.75 joule. So this is the work done by the resistive force. The work done by resistive force is negative, so displacement of raindrop will undergo the opposite to that of the resistive force. So students, you may note down this illustration. Now let us solve illustration number 3. A cyclist comes to a skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton and is directly opposed to the motion. How much work does the road do on the cycle and how much work does the cycle do on the road? So since the cycle is skidding, displacement and frictional force are in opposite direction. We know that when any object is moving on the road, right, the frictional force is provided by the road on the object. So here the frictional force is provided by the road on the cycle and it is opposite to that of its motion, that is towards it, opposite to that of its displacement. So here we can say theta equals to pi. The work done by the cycle in this position is Fd cos theta. Here we have seen that theta is equals to pi because the angle that is the angle between the force and the displacement both are opposite. So its angle is 180 degree. So here force is given as 200 Newton, displacement that is given as 10 meter and here cos pi that is minus 1. So when we calculate this we get minus 2000 joule. This work is negative, which indicates that kinetic energy is decreasing. According to Newton's third law, cycle exerts force of minus 200 Newton on the road, but no work done by the force and hence no displacement of the road. As a result, W equals to Fd cos theta, that is minus 200 into, here displacement is 0, into cos 0 degree. So work done is 0. So the work done by the road on the cycle that is 0 joule. That is no work is done by the road on the cycle. So students, you may note down this illustration. Now let us see illustration number 4. In a ballistics demonstration, a police officer fires a bullet of mass 50 gram with speed 200 meter per second on soft plywood of thickness 2 centimeter. The bullet emerges with only 10% of its initial kinetic energy. What is the emergent speed of the bullet? So in these data, what is given is mass of the bullet, that is 50 gram, initial speed of the bullet V0 equals to 200 meter per second, and initial kinetic energy of the bullet, that is K equals to half mv0 square, that is half into, here mass is given as 50 gram, that is you need 50 and upon 1000 into 200 square, that is velocity is given as 200, and here we have converted mass 50 gram into 50 into 10 raised to minus 3 kg. So when we calculate this we get it as 1000 joule. Now what is given is bullet emerges with 10% from the plywood with final kinetic energy. So we can write it as the final kinetic energy is 10% of the initial kinetic energy. So final kinetic energy can be written as half mvf square equals to 10%, that is 10 by 100 of the initial kinetic energy. Here 10%, that is 10 by 100. Initial kinetic energy, that is 1000. So when we calculate this we get it as 100. Now taking 2 and m on the other side we get Vf square equals to 2 by m into 100. Taking root on both the sides we get Vf equals to under root 200 and here mass is given as 0.05. So when we calculate this we get the value as root 4000 and taking the root of that 4000, we get Vf is equivalent to 63.24 meter per second. So here we can say initially the speed was 200 meter per second and now it is 63.24 meter per second. So speed is reduced by 68% and not 90%. So students, you may note down this illustration.